Okay, so we're going to have a very quick look at chromatography in proteins. So you should know essentially that proteins are made up of amino acids. And how can we tell what amino acids are in a protein? Well, that's quite easy, really. Or now it is with all the computer technology we have, enough to sequence proteins and things like that. But in days of old, they used to do this by chromatography. By days of old, I mean talking 20, 30 years ago, which isn't that long ago. You might remember chromatography from your GCSE chemistry. If not, there's a little clip on a little bite-sized page on there for you to have a look at. Essentially, chroma means colour, and it's basically a way of separating proteins, pigments within certain chemicals out to see what they consist of. Useful for things like forensics. You can analyse pigments in ink. You can analyse pigments in blood. Things like that. So it's really useful. So we're just looking at amino acids. It's a new bit to the spec. So in terms of what the board are going to ask, we will find out at some stage what sort of questions they will ask. So you see this first picture over here. This is essentially what has a 3D version of what you do. It's essentially separating a pigment using solvents. So we're going to be using acetone. So what you can do is a test tube, solvent in the bottom, okay, bit of chromatography paper, measure around about 1 centimetre and draw a pencil line there. Obviously ink would separate. On that pencil line you spot your pigment that you want to separate, or your compound that you want to separate into its pigment, so I say. That will then get placed into the test tube. Now this line here cannot be higher than this. Okay, so that line is going to be under there somewhere. What will happen is that solvent will rise. Let's change colour. That solvent will rise through the paper like that, and this compound here will be separated into its pigments. Okay. Before it gets to the top, you're going to stop. You're going to put a pencil mark there, and this distance here from the top to the bottom, that's your solvent distance, and then each of these values are obviously your pigment distance. Okay, you can work out what's called an RF value. It stands for retardation factor value. So all you do is you take your pigment distance, and you divide that by your solvent distance, and you get a value between 0 and 1. In order to find out what that pigment is, you can then go to the table of RF values and basically just check or compare against that, and you should be able to find the value that you've got on there. So I mean, this picture here is just a bit of showing basically your amino acid spots travelling up, and you can see the different amino acids are separating. And here we go. Here's a bit of RF value here. You've got your X values here over your Y value, which is actually this distance here. So we've done it with chlorophyll in the lesson. You can do it with any other protein. I'm sure you'll chat about it with carbohydrates. Have a look at the other videos I put up here. It's a bit of a whistle-stop tour, and we'll talk a little bit more about it in the lesson.